Hello everyone, welcome back to the physics class. On that day, we were learning about the continuous charge distribution, and in this section, what we learned about the continuous charge distribution, that means the charge can be considered as continuous in solving the problems, because even in a very small charge, microcoulomb charge, there are so many small charges, discrete charge carriers, that means electrons. So in real life, even if you take microcoulomb, there would be millions or billions of electrons, and you cannot keep on tracking each and every individual part separately. So instead of doing that, what we use is continuous charge distribution. In this topic, continuous charge distribution, we define three different type of quantities. First is this linear charge density lambda, which is simply the charge delta Q upon the length element delta L, where charge delta Q, that small charge on that small element. And next quantity was surface charge density sigma is delta Q upon delta S. So if there is a small area element which has an area delta S and the charge on this small area is delta Q, this surface charge density sigma is given as delta Q by delta S. And third element is the volume charge density. Volume charge density, or simply we can call it charge density. This is represented by rho. This is simply delta Q by delta V. That means there is a very small volume and charge on this very small volume is delta Q. Hence, we can define the charge upon volume as a quantity density similar to that we define density, mass upon volume. Similarly, we are defining charge density, charge upon volume. So this is linear charge density, is surface charge density, and this is volume charge density. Three types of density are there, and these are very important quantities to solve the real life problems rather than considering one particle discrete. Because if you think, till now we have encountered only one or two particles, or at max three particles, three charged particles. But if there are billions of particles, how will you solve those questions? So instead of considering them a discrete charge, you will consider them as a continuous charge distribution, and you know that what is their area, what is total charge delta Q on them, and then you solve the problems. So, and also we have discussed the units. For volume charge density, it is simply charge is in coulomb, volume is in meter square. So the unit is simply coulomb per meter cubed. This is quite simple. For this linear charge density, simply coulomb per meter, and for this surface charge density, simply coulomb per meter square, because area is in meter square. Okay. So now let us move further. So after defining these quantities, the field due to a continuous charge distribution can be obtained in much as the same way as for the discrete charges. So what we are doing is we are using the same principle for defining an electric field for continuous charge distribution, similar to as we did for the discrete charges. So see here, what is the electric field? Electric field is delta E. Simply this is the same constant, 1 upon 4 pi epsilon naught. This is the distance square, r prime or r dash, and this is unit vector r, simply. But now what you see, there is this charge has been replaced by this quantity. So previously charge was Q, this time charge is delta Q, and as you know, charge density rho is equal to delta Q upon delta V. See, they simply replace delta Q is equal to rho delta V. They have simply written that, and all other formula remains the same. So the formula for electric field is very similar to that of discrete charges. Only thing, instead of writing delta Q, they simply have written this rho delta V, that means charge density into volume, simply that. Rest the formula remains same. Now this r, where r dash is the distance between charge element p and r dash head is a unit vector in that direction from the charge element to p. Let us see this. See, if this is origin from where we are considering all the distances. Here this is that element on which there is charge is situated. So the total charge delta q is equal to rho delta v, the volume of this element into density, charge density, not normal density. The total distance, now we want a field to see on point P, this point P. So first thing is that the distance of this volume element from origin is r. Again, this is a vector quantity. The distance of this P point from origin is capital R. Again, this is a vector quantity. Whole volume is of this entity is V. Let us see later on, but this volume element is delta V. So the distance between this volume element and this point P is r prime. They have shown r prime or r dash to this. So what is r dash? R dash is simply r, capital R minus small r. So this is r dash. This is r dash. So r dash is the distance from distance of the point from this volume element, and volume element is small r distance from origin, and this is capital R. So simply r dash is capital R minus small r. Again, these are vector quantities. So in a way, we saw that electric field can be given in a very similar way, only thing replacing delta q by rho delta v, which is charge density into volume. Okay, now by the superposition principle, the total electric field due to charge distribution by summing over the electric fields due to different point elements. So what they are trying to say is, let us say this is our body and it is charged body, and we took a very small volume element on which there was charge delta q, and the volume was delta v. So what they are trying to say, we can divide it to many small volumes like this, many small volumes, and then sum them up. So total electric field is 1 upon 4 pi epsilon naught, that is constant, remains the same, and the summation for all volumes. So this remains same, rho delta v r prime square unit vector r prime or r dash, I always say prime, but that it means dash, r dash, and this sum over all delta v, all delta v. So there is nothing new. If there are 10 elements, we have summed all of them to get this whole area. If there are 20 of them, we again sum all 20 of them to get the whole area. So this is nothing new. So note that rho, r dash and r unit vector r dash all can vary from point to point. Yeah, this is an important point, since we are now taking many different volume elements. So charge density at different volumes, their position vector of different volume, so they can all vary from point to point. That means for different volume elements, r dash, unit vector r dash and charge density can vary from point to point. This is point to be noted. In a strict mathematical method, we should take v, delta v should be 0, that means very small, so this e should be exact. That's why we have put a nearly equal sign. Then the sum becomes an integral. If we take delta v is equal to 0, that means this is very small, then this summation will be replaced by an integral in that case. In short, using Coulomb's law and superposition principle, electric field can be determined for any charge distribution, any discrete or continuous, part discrete or part continuous, that all we can determine.